Hi, today we're looking at section 3-5, solving inequalities with variables on both sides. So again, take something out to write notes on, pause the video when you need to, and complete the check it out problems following each example. And bring any questions you have to class. Our learning target for today, I can solve inequalities that contain variable terms on both sides. So in solving inequalities, you can either collect the variables on the left-hand side or on the right hand side. And this is a nice comparison showing you which is which, the analysis of doing one or the other. In this case, on the left hand side, we had to flip our inequality because our variable was negative. On the right hand side, we moved the variables to the largest side, and we just had to move our inequality so a variable was on the left when we were done, just flip it over. But no, didn't have to change our signs at all. So study this and see which method works best for you. But the important thing is to collect your variables on one side. You have to get them together. So again, collect your variables, and you can pick the left-hand side or the right-hand side, whichever works. So here's an example. Y is less than or equal to 4y plus 18. So solving this, I prefer to keep my variables positive. So I subtracted y from both sides of the inequality. So on our left-hand side, we're left with 0, and the right-hand side, 3y plus 18. Subtracted 18 from both sides, leaving 18 on the left-hand side is less than or equal to 3y. Dividing both sides by 3, negative 6 is less than or equal to y. And we want to always put the variable on the left-hand side, so y is going to be greater than or equal to negative 6. So at negative 6 is our endpoint. We have a closed dot at negative 6, and we shade everything to the right. And again, check your solution. Our endpoint is negative 6. Plug that in and make sure the inequality holds true. So we have negative 6. Is that equal to negative 24 plus 18? And yes, it is. And then we can go ahead and pick 0 as see if that's going to be a solution or inequality. Is 0 less than or equal to 18? And again, yes it is. So by checking our solutions, we have the correct endpoint, and we have shading the correct way. Now let's look at our second example. 4m minus 3 is less than 2m plus 6. So again, keeping our variable positive, the left-hand side had more m's, so we subtract the 2m on the right-hand side from both sides, leaving us with 2m minus 3 on the left is less than 6. Adding 3 to both sides, 2m is less than 9, dividing both sides by 2, we have m is less than 9/2. So 9/2 is not part of our solution, but it's the endpoint. So we have an open circle at 9/2, and we're going to shade everything to the left. Again, check your solution, make sure your shading and your inequality sign is proper. And it's your turn now for these two examples. Solve the inequalities and graph the solutions on your check it out sheet and bring them to class. Example 2 is a story problem. The home cleaning company charges $312 to power wash the siding of a house plus $12 per window. Power Clean charges $36 per window, and the price includes power washing the siding. How many windows must a house have to make the total cost from the home cleaning company less expensive than Power Clean? So again, with any story problem, we have to define a variable. So we're going to let W equal the number of windows. And looking at the problem, they want to know the total cost for the home cleaning company to be less expensive than Power Clean. So our inequality to be the home cleaning company is going to be less than the Power Clean. Substituting the numbers, $312 plus $12 per window has to be less than $36 per window. Now we're into an inequality. 36 is larger on the right-hand side, so subtract 12w from both sides. Leaving 312 is less than 24w. Divide both sides by 24, resulting in 13 is less than w, or, with the variable on the left, w is greater than 13, which means our answer or solution to this problem is going to be more than 13 windows. And then it's going to be less expensive. Now it's your turn to check it out. These examples, now we're going to simplify each side before solving. And again, as with equations, simplify first and then solve. So with this example, we distribute the 2 to everything in parentheses, leaving us with 2k minus 6 on the left-hand side, and combine the 6 and the negative 3, so we get 3 plus 3k on the right-hand side. Right-hand side has more k's, so we subtract 2k from both sides, leaving us with negative 6 is greater than 3 plus k. Subtract 3 from both sides, so negative 9 is greater than k, or k is less than negative 9. To graph, open circle at 9, and we shade everything to the left. Now again, check your endpoint, plug negative 9 in, and you should get a true equation here. And then pick a number. You can pick 0, and check it. 0 should not be a solution. But again, check your solutions. Moving over to example B, we have 0.9y is greater than or equal to 0.4y minus 0.5. Okay, so we have 0.9y is larger than 0.4y, so we'll subtract 0.4y from both sides, leaving us with 0.5y is greater than or equal to negative 0.5. Divide both sides by 0.5, and y is going to be greater than or equal to negative 1. So graphing, we have an open or a closed circle at negative 1 because it is part of our solution, and we shade everything to the right. You guys should be getting pretty good at graphing at this point. Now it's your turn. You have these two examples on the check it out. Bring any questions to class. And our last example. Want to make note, when both sides of an inequality are fully simplified and the same variable appears on both sides of the inequality, then there are the two choices. The choices are either all real numbers will be a solution, that's one choice, or it will have no solutions. So we want to look at other terms in the inequality to decide which is the case. So look at our first example, 2x minus 7 is less than or equal to 5 plus 2x. Notice 2x is on both sides of the inequality here. So as we show down below, if we were to subtract 2x from both sides, we're left with negative 7 is less than or equal to 5. And that is true. So in this case, it's true no matter what value substituted for the variable. For these inequalities, all real numbers are the solution. So you write all real numbers if you end up with a true inequality, just like with a true equation. Look at our second example. When we distribute the 2, we simplify first. We end up with 6y minus 8 is greater than or equal to 6y plus 21. So again, we notice this, we have 6y on both sides of the inequality, and we end up with negative 8 on the left and 21 on the right. So as negative 8 is not greater than or equal to 21, so therefore the inequality is false. And we have a false inequality. That means this inequality has no solutions. Same thing as with a false equation. There are no solutions. So now it is your turn to do a check it out. Determine if these are all real numbers, no solutions, or if there actually is a solution. So in summary, with any inequality, or equation for that matter also, always simplify each side. If possible, keep your variable positive and determine the number of solutions for inequalities. If you end up with a true inequality, then your solution will be all real numbers. End up with a false inequality, then it's going to be no solution for inequality, just like in the last example we covered. So bring any questions you have to class, and thanks.